Students, welcome back to the second part of lecture number 3. So, we discussed in the first part the basic neural network or artificial neural network, and we talked about how they are delivered. So, you can have different types of networks, right. So, on the left side you see in the slide you have multiple inputs, but a single layer, multiple inputs you can see here, and these inputs are cross connected. And on the right side you see multiple inputs and multiple layers, basically 2 layers, right. That is what it is, but this is all the data is moving in the forward directions. You can also have a recurrent network. What is it? Recurrent network means it has a feedback loop, right. So, you see here we have 2 layers here, input layer and one hidden layer, output goes to the right side. But here after the hidden layer you can also have a feedback. Why it is required? Because many times whatever your output you are getting may not be 100% correct. That is the case always, there will be errors. So, feedback can be taken and error can be corrected. These are called recurrent networks. Please remember this word, we will talk about it a lot about recurrent networks in the future. So, how does this ANN does the learning? It is a supervised learning. So, inputs are taken from environment, fed to the actual systems, okay, as well as fed to the neural network. Then you detect the difference between this actual and neural network. That is what is your error is, right. So, that is how this happens. So, idea is any machine learning, deep learning algorithm idea is what? To make the error as small as possible, but how we can make it possible? Error analysis will help you to understand that. So, to give you in perspectives, here you have 4 layers, 2 hidden, 1 input and output layer, and you can see that in the input layer you have multiple data x1, x2 to xn. Then hidden layers also have first hidden, second hidden layers also multiple perceptrons, and finally output layer also has some and not perceptrons. Okay. So, how the signal and errors propagate? So, as you said, this is a feed forward network, that means things are moving in the forward directions. So, you feed into this first layer, it calculates and goes up. You can also have backward loop for errors, you can see arrows coming like this, right. So, that is how we can do this iterative process and calculate the errors involved. So, let us say an example, hidden layers transfer function is sigmoid function, which is nothing but a 1 by 1 plus exponential minus n. So, what is the derivative of this? Let me write it, fn is 1 by 1 plus exponential minus n. So, what will be f? Very simple, right. So, you can take 1 plus exponential n whole square, this multiplies 0 minus 1 into minus plus exponential minus n, that is your first derivative, right, exponential minus n, and next one is a square term. So, it does not make difference, square of any negative positive number, any exponential minus x is always going to be a positive number. Okay. So, that means you calculate that, okay, and that is nothing but output of the neuron multiplied by 1 minus output of the neuron. Therefore, f prime is a slope of the transfer functions, that is everybody knows. So, output transfer functions, if it is a linear, derivative will be 1, is it not? That is why we never use linear functions in ANN or for material science, we always use complex functions, because the moment derivative becomes constant, you do not calculate variations very easily, right. That is what it is, the problem is. So, if I have to put together in for you for understanding in a summary wise, step 1 takes the input, multiplies them by weights and then add biases, computes the sum. Why? Weights allow the perceptrons to evaluate the relative importance of each of the inputs. Otherwise, how do you know which variable is playing what kind of role? Some variables may play a strong role than some other variables. So, weights we allow to do that. Neural network algorithm runs by discovering better and better weights. So, weights are your free variables. Am I clear? Weights are your free variables which you can change. Similarly, biases are also free variables which you can change, but most of the cases biases may not be changed, but weights can definitely be changed. And we have to then develop algorithms that can fine tune the weights, and most important algorithm which is used widely is called back propagation. You see that? That is what is widely used. Okay. So, in second case you can add bias. Okay, here I already told you, you can always sum it over. So, what is telling is that this is step 1. Step 2, you can add bias. Okay. This is a technical step, because to move the activation function up and down, left and right. So, then you apply the activation function, I told you, let us not discuss further, and you get output, right. That is what you have done. So, now the question is how you calculate errors. Let us talk about something about that. So, before I talk about errors, let me tell you what is back propagation. Back propagation algorithm allows you to perform backward pass. In football you do that. This is what is the backward passes. So, you can see a player is taking the ball, move forward, he could have scored the goal, but he did not score the goal this way. He gave the back pass to this guy who is in the same line, and that fellow scored the goal. Okay? So, that is how it is called a backward pass. Why? Because this fellow has recalculated, if he hits the ball, the goalkeeper may stop, it will not be successful goal. So, this thought process can built in a back propagation network. So, hence it is an algorithm used to widely train neural networks. It performs iterative backward passes. Please remember these words, iterative backward passes, which attempts to minimize the loss or error. Error means difference between the actual and the calculated values or predicted values. So, each backward pass, weights will move back and forth towards an optimum value that can minimize the loss. That is the idea. When you do each time backward pass, you basically what you are doing, you are changing the weights, and this is done by simply taking the first derivative of the transfer functions. Okay. You know that when you calculate minimization of the transfer functions, you always take the first derivative, right, or maximization. So, when neural network is initialized, weights are set for the individual elements, and then inputs are loaded, multiplied, added, everything. Finally, you have to adjust these things. Okay. That is the idea. So, this is what this back propagation is. Now, without the knowledge this, let me go forward to the board and explain you how it is done. So, hope you understood the back propagation algorithm, right. So, this is the most widely used algorithm. Okay. So, now let us say x I is the input. Am I clear? And y is the output. This is what is the data you will have. You will have x I and y I, am I right? When you get the data from your supervised, any supervised learning techniques will have this kind of data sets. So, hence, so given a training set, given a training sets of input vectors, which are nothing but x I, like that, and you have okay, or I goes to 1 to n, right, and then you have also corresponding target, that means outputs, target vectors Ti. So, what is the error or loss function, whatever you say? Some people say loss. Machine learning loss is more widely used. So, error is nothing but W. We always write in terms of W because weights are written in terms of W. So, that is nothing but a half sum it over n or I goes to 1 to capital N mod y xi w xi comma w minus Ti mod square. This is what is your error function is. Please check it carefully. We sum the errors, okay, because there are many layers, there are many perceptrons, so you have to sum the error. So, y is basically your output, right? So, y is the output and t is the target variables, output of the model, okay, remember y is the output of the model and t is the actual value of the outputs. So, we are taking the difference between the output of the model and the actual output. Actual means if you do some experiments or if you do some other kinds of things, basically experiments, you get some values of the target. That is why it is called target. Target means output in the sense of actual values of the output, and this is your model predicted outputs. You take the difference of that mod of this. Why mod? Because that will take care of negative signs, and then square and add it up. This is what is called mean absolute error, okay. And then you simply basically you divide by n, not half, okay. So, that is what is your error is. Now, error backpropagation is adopted. So, backpropagation adopted what it does? The backpropagation does what? Let us understand that. What does it do? It simply evaluates the gradients of the error function. Gradient means slope. Of EW every step. It calculates the gradient of error functions in a feed forward network. Then that is what in a feed forward network which is going like this. Okay. These are your inputs. Like that. So, feed forward network, this is going in this way direction. So, you calculate the gradients of these error functions. So, you see here error functions is a function of w's, not a function of xi or t. So, when you take the derivatives, what you basically take a derivative with respect to y, w, right. W's are your weights, because weights need to be optimized in a neural network. That is what is done. So, at each step we can distinguish between these two distinct stages. In the first stage, derivative of the error functions with respect to the weights, okay. That means what? d E w by delta w. This is what is the derivative with respect to the weights must be evaluated. In the second stage, derivative then are used to compute the adjustment of the weights. So, first you calculate this, and then in the second stage these derivatives, or rather used to calculate or compute adjustment to be made to the weights. W's. Okay, that is what is done. So, these are the two steps. So, every time you calculate the gradients, use the gradients to compute the adjustments. How do you compute? Because if gradients are diminishing, that means your error is reducing, right. If that is how you should follow it up. So, now as you said, if I light, so total error is what? Is nothing but a summation of all errors, because this is one step, right, because you have many steps. So, total is summation of all the errors. Am I clear? And your output yk is sum it over w kj xj plus sum it over in the last. The output is, this is your output. So, it is operated here in this layer. So, plus w k 0. Am I clear? That is what it is. So, now we have outputs, we have errors. What is that we do? We simply take derivatives of that and calculate difference between these two, and then find out what is the error involved. Am I clear? That is the basic idea of finding out errors in this kind of systems. Okay. So, we will talk about more of these back propagation networks, and there are other techniques also how it is possible. In fact, as a part of these exercise in the next lecture, we will show you how we can estimate errors in a very simple system like this. You can see that there are two layers, hidden layers, input and output layers. We will see how this can be done. So, with this let me stop here, and we will come back to you the next lecture, most are discussions about the neural networks. Thank you.